Now there are some terminology which are related with CPM and PERT. So let's discuss them. Terminology related with PERT and CPM. So number one is event. Number two is activity. Number three is network. Number four is path. Number five is dummy activity. There are a few more that we will be discussing when we will be drawing networks. So first is event and activity. What is an event and what is an activity? So activity is the work which is done to complete a project. Every activity has a start event or and the end event. So for example, this is an activity A which takes time, for example T1. So it will have a start event and it will have a end event, or it is also called as, this is a start, it is also called as tail event, and this is the finish event, it is also called head event. And this is activity. Then there are few situations where two activities have a same end event, so that is called merge event. So there is an activity A and there is another activity B, and they have same end event, is called merge event. Similarly, there is another situation when the two activities have same start event or the tail event. So two activities, for example A and B, they have a same start event, it's called burst event. So this is about event and activity. Then network is a graphical representation of project, and it consists of series of activities arranged in a logical sequence and shows interrelationship between activities. For example, there is an activity A which takes time T1. For example, it has a start event 1 and it has an end event 2. Then there are two activities which burst out of 2. This is activity B, it takes time T2. It is activity C, it takes time T3. It has an end event 3, it has an end event 4, and then these two activities, they merge at 5. This is D, it has time T4. It is E, it has time T5, and finally this is 6 and it is activity F, it takes time T6. So this is a network. It has a series of activities arranged in a logical order. So there is one more thing which is dummy activity. We will be discussing it later also. As there is a word logical, so they 3 and 4 can be connected to make it a logic complete. So this is called dummy activity. This is dummy. So a path can be 1, 2, 3, 5 and 6. This can be path 1. There can be path 2, can be 1, 2, 4, 5, 6, and there can be a path 3 also, which can be 1, 2, 3, 4, 5 and 6. So it is considering dummy activity. So this is called as a network. And these are paths. These are paths. So there is one more thing which is called as a predecessor and successor. So successor is the activity which is after it, and predecessor is which is before it. For example, A is predecessor of B and D is successor of B. So every activity can have a successor or a predecessor also. Then there is dummy activity. Dummy activity is when two activities start at the same instance of time and do not consume time or resource. It is generally used to maintain the logical sequence, and it is generally denoted by a dotted line. For example, there is an activity P which ends at an event this, and out of this there is another activity which starts. It's called R, and similarly there is another activity Q, and it starts it finishes at an event, and out of that event there is another activity which is S. So in this network there is no logical sequence between these activities. So to make a logical sequence, what we can do, we can connect it with a dotted line. So this dotted line or dummy activity will not be taking any time or any resource. It is just to make a logical sequence out of the activities. Another example is, for example, there is an activity A which has a start event and it has an end event, and there is an activity B, it is also has a start event and activity and an end event, and it finishes at 4 at activity C. So if we make a path out of it, so one is 1, 3 and 4. This is path 1. And if we make path, another path, it is 1, 2, and it can't be reaching the final event or the final activity. So to make it logical, what we can do is we can connect 2 and 3 with a dummy activity, and as I told, it will be taking no resource and time. So it will be 1, 2, 3 and 4. So this is about the terminology related with CPM and PERT. Now let's take some examples and draw simple networks out of them. So the first example is, let's consider a list of 4 activities for making a simple product. There is an activity A. It has a description: buy a plastic body. Immediate predecessor is nil, that is, it doesn't have any activity before it. Similarly, there is an activity B. This is design component. It also doesn't have its immediate predecessor. Then there is an activity C, make component. It has an activity predecessor as B. So that means C can only be we can start activity C once the activity B is completed. So it will be following B. And finally, activity D is assemble product. It has immediate predecessor as A and C. So D can only be starting after we have finished activity A and C. So as we can say that A and B doesn't have any immediate predecessor, so the starting event of A and B will be the same. So it will be event 1, and out of it there will be 2 activities, A and B. A and B, because they don't have any immediate predecessor. So it can be event 2 and it can be event 3. So then what is event C? Activity C, sorry, has an immediate predecessor as B, and D has A and C. So C will or can only be starting after the activity B is finished. So this will be activity C, and D will only be starting once we have finished A and C. So this will be activity D, and this will be event 4. So now we can just check whether we have satisfied all the conditions. So A and B doesn't have any predecessor, so they are starting, they don't have any predecessor. C has a predecessor B, so C has a predecessor B. B, when it will finish, then only C will start, and D will be only starting once A and C are finished. So in this way a simple network can be drawn. So let's see another example. So this is an example. In this there are 5 activities which are given and immediate predecessors are given. For example, A doesn't have any immediate predecessor, B doesn't have any immediate predecessor, C has predecessor as B, D has A and C, and E has C. So as in the previous problem, so the starting event of A and B will be the same. This will be A and this will be B. This can be 2, this can be 3. Then the next is C will only be starting once B is finished. So C will only be starting once we have finished B. This can be 4. Right. And then D will only be starting once we finished A and C. So D will only be starting once we finished A and C. And now we have not joined this C in this fashion because it is given that E will only be starting once we finished C. So this will be E. So now to make it logical, what we can do is we can join these two events with an activity called dummy activity. And if we would have joined activity C with this one, so we will not be following the condition that E has a predecessor C. So to make it logical, we have drawn it in this fashion. Let's take one more example. This is in this activities are given, and it is the same example that we have discussed in while discussing the network. It has given activities A, B, C, D, E and F, and given immediate predecessors and successors. So for example, A doesn't have any immediate predecessor, but it has two successors B and C. It has two successors B and C. So activity A can be drawn as A 1 2. Then it is given that it has a successor B and C. So out of A there will be B and there will be C. Sorry, B and C. 3 and 4. And it is given that for activity B, immediate predecessor is A, which is we have already done, and the successor is D. The successor is D. And for activity C, predecessor is A, we have already done, and successor is E. Successor is E. And for D, the successor is predecessor is B and successor is F. And similarly for E, predecessor is C, we have already drawn, and successor is F, and for F it is D and E. And in the similar way, what we can do is, to make it logical, we can join these as dummy activity. So in this way, this network can be drawn. Let's take another example. Now let's take another example. This one a little bit complex. So it has activities A, B, C, D, E, F, G, H, I, J. It has also time given corresponding to each activity, and the required predecessors are also given. So before drawing it, before drawing the network diagram, what we have to see is, first we see what are the predecessors for each activity, and accordingly we draw it. For example, it is given that for A, B and C, no predecessor is required. So we can simply draw, for example, it will having the same start event. It will have A, B and C. A, B and C, and their times are also given 2, 3 and 4. So they will have an end event like 2, 3 and 4. So then for activity D, it is given that predecessor is A. So simply we can draw activity D, and it will have a time of 1. Right. Now if we notice that for activities E and F, required predecessors are B for each. So we can say that E and F. So we can say E and F. This is E and this is F. Time is 2 and time is 5. Right. So it is also given that for activity G, the predecessor is C. So simply we can draw activity G, and it has time of how much? 7. Right. So we have finished up till G. So we can say that activity H has predecessors D and E. So D and E will have, they will be merging, and out of that it will be coming another activity which will be H, and it will have a time 2. Right. And we can also see that for activity I, F and G, they are having the same, what do you call, merging at 6, and out of it they are having another activity which is the last activity, that is J, 8. J has time 1, and this is I, and it has time 3. So in this way we can draw this network.